Join me in welcoming Siamak. Siamak is a product engineer at Red Hat and drives CI/CD and GitOps initiatives on OpenShift, Red Hat's enterprise Kubernetes platform. Siamak, thanks for joining us today.
Thanks, Sarah. I'm happy to be here, and welcome everyone to ArgoCon. I want to talk to you today about the journey that we see a lot of organizations and teams that we talk to are taking from DevOps to GitOps. So what problems they have run into that GitOps is really unblocking them and allows them to progress in their adoption journey. But before we get to that, I wanted to level us a little bit about what we mean by DevOps and refresh your memory. This is something that most of you, perhaps all of you, are familiar with, given the popularity of DevOps and the statistics and numbers that we see from the number of organizations that are adopting DevOps from various analysts and the conferences. The reason for DevOps, the main driver is that a lot of organizations want to be able to deliver better software much faster, to be able to deploy more frequently, bring the changes to their customers, but also at the same time maintain or increase the quality of that software. And the reason for that is that a lot of us, regardless of what kind of industry we are, including like my company, Red Hat, we are usually in three categories of challenges that we face. We're either a traditional organization that have existed with older business models, and now we're getting pressure from newer competitors coming into the market, focusing on digital economy, and we have to reinvent ourselves, find new ways of doing business, bring our know-how and expertise and that competitive advantage that we have, reinvent it, transform it into a more digital way to compete with those competitors. There is another category that are those newer competitors that the first category of challenges are competing with. So smaller actors, often that the software is really their competitive edge. That's how they are winning against their competitors. So it is their bread and butter. They have to be able to deliver faster. Otherwise, they need to be able to come to market with innovative solutions really quickly. Otherwise, the larger players, the larger competitors would take away their market share. And the third group of challenge, the third group of companies we see is that, which is quite apparent in fintech, in the financial sector, for example, is that the consumer behavior is changing. The users are moving, for example, when you look at a banking sector from web to mobile devices. In Europe, when you look at the stats, for example, most of the users do their online banking through their mobile phones these days, not on the internet banking anymore. And gradually there is a move toward smartwatching and Apple Watch. So the financial organization needs to be able to cater to these new behavior users, and they have to be able to release software, and that becomes something that helps them to keep the customer, to be able to compete. So regardless of what the driver is, what is very common between organizations, regardless of the reason for that, is that they need to become a lot faster than they are, more agile, deliver quicker with better quality. And that's how DevOps got a lot of attention, because it's a problem, it's the way you're working, it's a movement that really focuses specifically in these values, in solving this problem for a lot of organizations. And the DevOps itself, I'm not going to define it here. Again, you're hopefully familiar with that. But the gist of it is really focused on collaboration. It's not a thing. It's not a process. It's not a workflow, but rather a way of working. Like a movement, perhaps, is the best way to describe it. It's a mind shift. It requires quite often a change in the organization, how our teams are aligned and working together. Their workflow and process changes, obviously, and there are technologies that goes with that. So DevOps talk a lot of the values and the ways of working at an abstract level. And at the same time, it brought to the table a list of practices and principles to help us realize these values. Continuous integration, perhaps, is one of the most famous practices that comes from DevOps, or most popular ones. Automated testing, version control artifacts, high trust culture, and a lot of more practices with varying level of difficulty in realizing them and incorporating them into organization because of the dependency that they have on the organization culture, on the structure of the organization and the workflows that are in the organization. Most teams, a lot of organizations that I speak with, they have quite often started with continuous integration. They have forgone they have skipped a little bit the organizational structure, focused a little bit on the process and a lot on the technology. And CI has been really a piece that a lot of these teams start with, and that there's a lot of value in implementing continuous integration and being able to bring more and more aspect of software delivery into an automated CI and remove errors, make it repeatable, and bring it closer to when development happens. But scaling it and moving beyond that has proved to be quite challenging for a lot of organizations, for a lot of teams. The question we get quite often from our customers is that, how do I proceed? So I know about the values of DevOps. I know about the practices, the principles, but what do I do next? Where do I go from here? Should I pick a new tool now, or is my team is changing in a way? Or do I need to bring new skills in the team? It's not that prescriptive, and that's one of the problems, or like biggest barriers of adoption that we see among customers, that they can't really evolve after a certain level, because intentionally DevOps is about values and abstract concepts, and is not a prescriptive way of achieving those. So if you look at 100 organizations that are adopting DevOps, it's very likely that you see 100 different variants of DevOps adoption, different tooling, different ways of working, different ways that are more suited to those organizations, right? But the challenge is that every single organization has to go figure out, what do they do next? What's the next? How they should do that? And another shift that we see alongside this happening is that initially most DevOps practitioners focused on CI, like I mentioned, and that's the most perhaps obvious step for bringing to the organization. But gradually we are seeing that these organizations are just shifting their focus to CD, not that they have a solution for it, but rather to raise the problems and have reached a maturity that are figuring out, so what do we need to do to be able to expand our DevOps adoption and the level of automation that we have, and the collaboration and the process changes into our CD process. CDB here continues delivery, focus on deployment and delivering actually the application that is produced to those environments that it needs to run, and to where it needs to be delivered to the customers. And this is really where we see GitOps coming to the picture. And GitOps provides quite a descriptive way of how to implement CD as a part of DevOps adoption. So it's you could call it the blueprint of continuous delivery under the same umbrella as DevOps. It's perhaps a new buzzword, but it's really in one section of really DevOps set of practices and values. And what the value provides to a lot of our customers that is extremely prescriptive. It shows exactly what you need to do next and how you need to achieve that. You might make choices of technology on other aspects along the way, but it's very obvious and descriptive of how you need to do next and how you need to implement it. To define GitOps a little bit, you probably hear that multiple times throughout this day, but fortunately I'm one of the first sessions, so you might not have heard this before. But from the way that we define GitOps at Red Hat, it's really a developer-centric approach to continuous delivery. And I speak a little bit about why developer-centric in a minute, but the idea is quite simple, frankly. The idea is that you treat everything that touches your application or infrastructure as code. This is essentially infrastructure as code practice of DevOps said in a set of different words. So you treat everything as code, you put everything inside your Git repository as a single source of truth. So the source of truth is not your cluster or how your infrastructure look like. It is what you have stated in declarative in those Git repos, and they are version control, and they're traced and tracked, and all the changes are visible in those Git repositories. I already address a question that I get asked quite often about this. Does it have to be Git? No, it doesn't have to be Git. But because of the GitOps terminology, I'm going to stick to Git. Any version control would do here. And by the way, I forgot to point out, because of the nature of the session, I can't pause to answer question, but please do go ahead and answer your questions in the chat. I'm going to spend some time in the end and try to pick a few of them at least and answer and speak about them. And the last part, and the most important part really, is that operations are driven through GitOps workflows and are automatically reconciled with the state that you have Git repo. What does that mean? If you need a change on some environment, that change might be you're changing the cluster configuration, or you are deploying a new version of the image of your application on that environment. That change is represented by a change in the Git repo, often in form of pull request, reviewed, merged to the repo that is the single source of truth, and there are tooling in place that automatically reconcile that change, that operational change or ask that is made on the Git repo is automatically reconciled onto those environments. And this is also really where we see the distinction. A lot of the organizations that have started from CI and tried to expand into CD in their DevOps adoption, they have done so by really relying on the same set of processes and tooling that they have for CI, and just at the end of that deploy to the environments, right? Which realizes the first two part of how I define GitOps, but it has huge lacks on the last part of it, because the CI process is also essentially a workflow process. You fire and forget about it. So you ask operationally for something happen, deliver the new version of this image to that environment, and see if it's successful. Yes, successful, forget about it. I don't know anything more about it. In the true definition of GitOps and implementation, your tooling needs to make sure the technology that is in play makes sure that the state of your cluster is always in sync with the state of the Git repos that you have in the source of truth. So this automatic reconciliation happens continuously. And there is actually an official definition that just came out of the last KubeCon from the GitOps working group as a part of CNCN. It's called Open GitOps, and the website is on the slide. Please go take a look. There are four principles as a part of GitOps that are represented here with this three circles. There are actually four that talk about the same points. And they definitely encourage everyone to get involved in that working group. For anyone that is interested in GitOps, it's a great forum for bringing use cases and talking about the best practices in that aspect. So how does this work in practice? It's quite simple and familiar. You have a Git repo that you define what you expect, the desired state that you have. Those are the declarative configs and what you declare inside a Git repo. So if you have an application on Kubernetes, that's most likely a deployment YAML or service YAML or ingress and things like that. And on the right-hand side, you have your infrastructure. This is the actual things that you have on the cluster, the infrastructure underneath it, and the applications on top of that. And the CD tooling based on the GitOps workflow sit in the middle, and they constantly compare these two sides. If there's a change in Git that is not available on that infrastructure, then it realizes that, actualizes it, and makes sure that desired state is reflected on the current, so that becomes the current state of your infrastructure. Or if there's a change on the right-hand side on the current state doesn't match the desired state, it can roll it back to the desired state that you have in Git. And that is extremely powerful from a security perspective. So imagine that the right-hand side of the cluster or infrastructure, there is a breach. Somebody goes and changes the image of the deployment that you have on your Kubernetes platform. Often in that CI-based implementations of CD, that change would go completely unnoticed. You wouldn't know immediately that something has changed in that aspect until this is manifested in some other way in your infrastructure, and that you might realize that there are some suspicious things happening. as a part of the GitOps workflow, because that comparison happens continuously, the GitOps tooling would immediately pick up that there is a change in the cluster that is not reflected in the Git repo, is not in the desired state that I want from that cluster. And the tooling might decide that automatically revert that to what you have in the Git repo, basically roll back to the well-known image that you have actually produced. It's not a raw image. Or at least notify an admin or someone to come and take a look at that. And the reason I said that developer-centric, that this is really something that like out of a Git repo and the Git workflow is something that all developers are familiar with. This is quite a standard workflow for most application developers, and this is something that is quite established in most organizations. So most organizations are quite familiar with this. Another value that you get beyond security out of the GitOps workflow is multi-cluster consistency. And this is really a huge point that we hear from a lot of Red Hat customers. That is a huge pain point. Most organizations that are operationalizing Kubernetes, they are becoming quite comfortable running a lot of the instances, because operation of Kubernetes is becoming easier and easier. And if you look at a platform like OpenShift at Red Hat, installing and updating a cluster has become extremely easy. The consequence of that is that a lot of organizations prefer to have a lot of instances of Kubernetes, but small clusters. And the challenge that comes with that is, how do I keep all of this in sync? How do I keep them consistent? And the configuration of those clusters are the way that I expect them to be. Or if I want to deliver an application across a large number of clusters, 50 of them, how do I make sure that this is happening consistently? And the GitOps workflow, because it's driven out of a single source of truth from the Git repo, it solve that problem quite nicely for a lot of customers. And this is actually seen that a lot of customers that are looking for expanding their CD, they're coming from this challenge of how do we ensure multi-cluster consistency. At Red Hat, we try to enable customers on top of OpenShift through Argo CD and Tekton, Jenkins, and Shipwright, a number of technologies from C and CF. I already talked about how that the DevOps, there are a lot of confusion on how to process it. If you look at the technology landscape that matches the DevOps landscape, and we can see a lot of them in the C and CF technology landscape, there are fortunately or unfortunately, there's a huge number of technology and framework that are active in this space, which gives a lot of choice, but also makes it extremely difficult to find the right path. So in OpenShift, we try to bring the best of breed of these technologies on the platform, enable customers to use that. Argo CD is the core of OpenShift GitOps, and Tekton is the core of OpenShift pipelines that together provide a DevOps platform for customers to be able to implement GitOps workflow for any Kubernetes platform, really. But how does that work in practice? Like what challenges within the DevOps adoption this approach solves for customers? So if we look at OpenShift Python and OpenShift GitOps, it's the core of the GitOps workflows on top of OpenShift to Kubernetes cluster for customers, with Argo CD being really the engine of reconciliation, fulfilling the CD capabilities based on the GitOps principles, and Tekton being the CI core, fulfilling the CI capabilities of DevOps adoption. Combination of those two will become a powerful foundation for applying GitOps for application delivery. When I have built my application, I want to deliver to a large number of clusters or namespaces in a consistent way, and make sure that I can recreate those environments at any time I want, or I can identify any drifts that might be happening in those environments. Or if we want to keep the clusters themselves in a consistent shape with configuration management, and OpenShift has Kubernetes in essence is an extremely declarative platform, but there are still a lot of configuration in it that needs to happen at the infrastructure level. Within Red Hat and OpenShift, they have focused a lot to bring a lot of those configuration also as declarative configs into the platform that are applied to the platform. What does that mean? If I want to configure authentication on top of OpenShift, that's essentially a YAML that is applied to the cluster. If I want to add multiple nodes to the cluster to scale it up, that's another YAML that is applied to the cluster. So that makes it quite easy to manage the configuration of cluster itself, not just the application, using Argo CD and a GitOps workflow that provides an extremely powerful combination for customers that have multiple instances of Kubernetes and want to bring consistency in managing the configuration across those. And because all of these CI/CD technologies are really focused on any Kubernetes certified distro, like quite easily support hybrid cloud infrastructure that many of the customers have, with a part of the infrastructure and application being on premises, perhaps on Red Hat virtualization or VMware or OpenStack or something else, combined with a number of Kubernetes distros from Kubernetes services from public cloud, maybe AKS and AKS, and the same CI/CD workflow can look at the same Git repos and push these changes across all these clusters, regardless of what kind of infrastructure they are, if they are on premises or public cloud. But as we speak with customers about their use cases of GitOps, we quite quickly realize that the number of use cases that customers are looking at and at GitOps for solving some of the challenges they have is much wider than application delivery and cluster configuration. There are actually a lot of use cases that customers come to us and talk about the edge use cases. They have software that runs on edge devices or close edge, and there are thousands of them, and they want to be able to deliver a piece of application that runs on that edge device in a controlled manner and consistent manner. And by the way, that edge device doesn't have connectivity all the time. You're looking at still the same core of OpenShift pipes and OpenShift GitOps to be able to enable them for application delivery on edge devices or configuring the edge devices through Argo CD. There are fleet management and multi-cluster management use cases. So we always imagine that the GitOps workflow applies to when you have an infrastructure and perhaps you have a Kubernetes cluster, you want to deploy application on it, you want to change the configuration on it. And the use case that we have discovered customers talk about and they look at Argo CD to solve it for them is that we don't have any infrastructure. We're talking about day zero. We don't have any cluster. How do I point at a Git repo and out of nothing, I have suddenly Kubernetes that is up and running and is brought to that base configuration, golden configuration that we have at our organization. Supply chain security and governance and compliance, and another aspect, compliance is really as good as the policies that you have applied to that cluster. But who is responsible for making sure that the correct number of policies are applied across the fleet to the clusters that you have in your organization? And they're looking at Argo CD for as a vehicle for delivering the policy combined with other products. MLOps being another aspect, and there are many more use cases actually that incrementally we keep discovering with customer. And because of that, like there are more and more integrations and technologies come to the picture that together with Argo CD and Takedown solve these aspects for customers. An example of that is Red Hat Advanced Cluster Management that integrates with Argo CD to handle multi-cluster management and edge devices, all from day zero to day 2. There's Red Hat Advanced Cluster Security that focuses on supply chain security and governance. So we have the policies delivered by Argo CD to the cluster, but somebody got to verify those policies against defined policies, to be able to generate a report, be able to reject certain activities on those clusters based on those policies, and all of that are taken care of through advanced cluster security or advanced cluster management. And to take that even beyond just Kubernetes clusters, Red Hat Ansible provides ways that we can apply GitOps workflows even to layers underneath the Kubernetes. That's another question that we get quite often. Is GitOps really only existing on the Kubernetes platform? And the answer is really no. GitOps is a workflow that would apply to any layer of infrastructure that you can describe declaratively. But layers below Kubernetes are often not that declarative, and you need to employ other technologies, other tools that can bring some level of declarative nature, declarativeness to that aspect of the infrastructure. And Ansible is a tool that does a really good job as that at that, and combined with the core of the GitOps tooling that we have, you can even expand the scope of the GitOps workflow beyond just Kubernetes and push it further down in the technology stack to the infrastructure that runs underneath. So to give you a little bit more of a concrete example of how this will look like in an application delivery and how these workflows look like, so in the CI part of this diagram is it might be quite familiar with you for you is how most CI technology or CI workflows look like. You have an application Git repository that contains the source of the application. The Git event triggers a pipeline, some sort of pipeline. On OpenShift, there will be the takedown pipeline, and a series of activities happens that might be actually be multiple pipelines. This is quite a complex step in the middle that I'm representing with a tiny icon. And the application is often released as a number of container images that go into an image registry like Red Hat Quay. And advanced cluster security in this sense brings DevSecOps integration into the CI process, that it can scan the changes and even like sign the images that are produced to be able to check vulnerabilities, CVEs, and bring those kind of security checks a lot earlier in the process into your CI. And when you look at the CD flow, the CD workflow based on the GitOps workflow, that would be a different, quite often, it could be the same, but quite often a different Git repository that contains configuration, and there's Argo CD in between that is in contact with the clusters that these changes need to go to, and it pushes just changes to those clusters. Or if Argo CD is sitting on those clusters, in the case of the edge use case that I mentioned earlier, Argo CD would be sitting on the cluster because connectivity is not always there, and it would pull those changes into the cluster, pull the images from the cluster, and there would be compliance and policies that on those clusters checked against advanced cluster security or any other security tool or DevSecOps tool that would exist in your organization. And looking at scaling that, advanced cluster management or any type of fleet management helps you manage the lifecycle of those clusters as well. So we do see customers that as a part of their CI process already in that CI, they do test deployment of their application, provisioning a cluster from nothing, so that they are sure that the cluster doesn't have any changes that they don't expect based on that set of configuration they have in Git repo, and they deploy the application on it and decommission the cluster after that. And advanced cluster management from Red Hat is a product that enables those kind of variations of CI, expand it to not just the application, but take it all the way to the cluster, and also helps with some aspects of compliance. And with that, I'm going to thank you and end my session here. Move to see if there are any questions that I can answer in the remaining time.
Yeah, that was amazing. Thank you so much for that. And there are a ton of questions in the chat. And so just to keep us on schedule today, I'd like to invite you to ask your questions in the chat of Siamak, and he can answer those directly for you. And then we're going to jump to the next one. It's been amazing having you with us today.
Thank you. It was my pleasure.
Thank you. See you guys in the next one.